Thank you very much for connecting this afternoon. My name is Margherita Volpe. I work in Zabala Innovation together with Francesca Pasqualino, and we are part of the project Magician, who is organizing the open call for proposals that you have been reading about, and that will be the object of today's presentation. Here we have also the coordinator from the University of Trento, Daniele Fontanelli, who will present an overview of the project, and there will be also a moment for specific presentation of the different technologies that are in target for this first open call. First of two open calls, actually. There will be a second one published in December, and the first one is already open, and we hope that you have had already the chance to check some details, and you're here with already some awareness about the calls. In any case, the presentation will cover the full spectrum of details related to this opportunity for funding. Deadline on May 2nd. So we are very much looking forward to receive your applications, and the webinar of today is an occasion to give you more detail at this regards. Besides this, at the end of the presentations, you will have the opportunity for a question and answer session. In the meantime, during the presentation that we are gonna give, I kindly ask you to write questions in the chat section so that we can be aware of them and manage it better during the question and answer block. And again, as you will hear, there will be further occasion to interact with the consortium by means of a weekly help desk that we have organized for interacting with potential applicants every Wednesday afternoon. All of this, much more, will be the object of today's presentation. So without further ado, I leave the floor to Daniele Fontanelli as coordinator of the Magician project for the beginning of this presentation.
And today I will give you an overview about the solution that we are aiming to provide within this project, and also what is the let's say the main technical developments that we are doing upon which the open call is built upon. So what is Magician? Well, Magician is a European project. We have 11 partners that are joining together, and the main purpose of the project is actually to address, let's say, defects in manufacturing process. So the main idea is to try to understand if it is possible, by the use of robotic systems, to understand if there are some defect that comes from the production of goods and materials, and then to also provide an autonomous robotic solution that make up for these kind of defects. The main, let's say, use case that we are focusing on at the beginning is the automotive process. So we try to, let's say, design a modular system that comprises mainly two types of components. One is related to the, let's say, detection of defects, mainly aesthetic defects. So on the car chassis, which may be generated by wrong welding processes. So you may think about welding spatters that comes from let's say melted metal that goes onto the chassis of the vehicle, and also dents and other type of defect that turns out to be very nasty when the chassis goes to the painting process. So the main solution, as I said before, relies on two types of robots. One robot, which is called sensing robot, is devoted to understand if there are defects and where they are placed, and also what is the, let's say, the extent of the defect. So we have to classify the defect in order to give information to the human workers, but also to the cleaning robot module. That is instead a robot that is equipped with a grinding tool that is able to remove the excess of material on the car chassis. So these two type of components should be modular, which means that we can have applications in which both the robots are together used inside the production line, or maybe there can be some companies, some industries, some manufacturing process that needs just one of the two. The two components tries to, let's say, make the most out of the experience of human workers. So there will be some artificial intelligence module, mainly imitation learning module, that try to, let's say, imitate the work that is actually carried out by the human worker nowadays. And the point is to help them in, let's say, helping them in all that kind of operations that may be, let's say, unhealthy. So, for example, if you think about the grinding solution, so the fact that a human being should have in one hand a grinder in order to remove the excess of material on the robot chassis, this type of work usually generates a lot of, let's say, dust. That is, of course, something that may be very dangerous if breathed by the human being. And also the user has to carry out this type of operation in an, let's say, non-ergonomic way. So he has to, stay in positions that are not so relaxed. It is also very stressful for the human body, for the muscles, for the skeleton. So we try to, let's say, remove the human worker for those kind of operations that are unhealthy and also non-ergonomic. So what does it mean? It means that in carrying out this kind of operation, this kind of help, let's say, we are trying to use a human-centered approach, which means that we try to ask the human worker how they are carrying out the job, what could be the best help that they can have from the system, and what are the, let's say, best possible, let's say, help that we can give them in the production process. So we have, as it is nowadays the standard, in the industry 5.0, the human should be in the center of the development of the system, because we actually want to help the human worker, not to entirely remove the human worker from the production area. In this, as I said before, we focus mainly on the automotive industry, and so we are planning to, let's say, put these two robots into the production line, so in the production area. And so these robots should have a lot of features. Some of them are related to safety. So we are thinking about having robotic arms that are collaborative robots, because at the moment we do not have, or we do not believe that a solution in which the robot is segregated with respect to the human being is a winning solution. So we are trying to, let's say, put the automation together with the human worker. So the robot should share somehow the space with the human worker and should somehow imitate the way in which the human is carrying out the job, and trying to, let's say, again, try to remove the human worker for these stressful and unhealthy conditions. In doing so, we want to, the main objective of Magician is actually to develop this modular solution that is intelligent, that is helpful for the human being. And in order to do so, we have to, let's say, satisfy a set of benchmark that, of course, the robot has to do the job in the same way as the human is doing. So it has to be, let's say, effective in the same way. And also it has to improve the productivity in manufacturing and maintenance. And it has to be safe. It has to be a solution that makes the human worker life easier and surely healthier. And one important thing that we have to think about is that this kind of the two operation, that is sensing and removing of the facts, should be carried out within very stringent task time. So we have something like 1.5 minutes, a couple of minutes to cover entirely the vehicle using the sensing system. So we have a very short amount of time to detect all the defects that are on the car chassis, and on the same time we have more or less the same couple of minutes to actually remove all the defects from the car chassis. This is, of course, a very, let's say, challenging task that we are aiming at. But at the same time, we actually believe that the fact that we are endowing artificial intelligence and we are trying to, let's say, imitate the work that is carrying out by the human worker would help us in meeting this kind of challenging targets. This is the main body of Magician. And another couple of bit of information that I want to share with you is the fact that in the first open call, we are asking for, let's say, solutions, available solution, or additional, let's say, features that our solution may have. So enhance the sensing system, enhance the capability to rework the defect, and so on and so forth. And in the second part of the project, we will try also to extend the applicability of our solution. So the automotive industry is just the first use case, but then when we go through inside the Magician project, we will have additional use cases in which our solution could be applied. So this is, I would say, the overall presentation is a 4-year European project. We have 11 partners, as you may see in the slides. This webinar is concentrated on the first open call, while the second open call will be focused on, let's say, new additional use cases in which our solution could be applied. And in the picture, you may see all the partners of the project all together in the kickoff here in Trento. And I suppose that this is pretty much it for the general presentation of Magician.
Thank you, Daniele. So now it's the part of the administrative operational details of the open calls and the cascade funding in general. I present myself again. I'm Francesca Pasqualino. I work in the European project team for Zabala Brussels, which is a Magician partner who takes care of the cascade funding activities. The cascade funding activities for Magician is composed by 2 open calls that identify and select proposal from SMEs and startups for experimentation. In this moment, we are, let's say, in the period of launch of the first open call, as both Margherita and Daniele said. The main scope is the integration of new functionalities with the Magician project. The open period is from February 3rd to May 2nd, 2025. 5 projects will be selected and will be funded for 200,000 euro of budget. And there will be launched a second open call from December 2025 to March 2026. The general scope will be slightly different because there will be focus on the application of the functionalities on new use cases, as Daniele mentioned before. However, other 5 projects will be funded for the same amount of budget. For both open call, the application solution will be implemented for a period of 12 months. So let's focus on the first open call, which is the integration of new functionalities within Magician project through a close collaboration with a Magician partner. The aim is the enhancement of the capabilities of the sensing robot and the cleaning robot. It's important to know, as is outlined in the guide for applicant, that application solution must select a single module and specify the chosen module in the proposal stage. So it has to be specified both in the summary and the excellence that are present in the template of the documentation of the first open call. The two modules are the first one, perception, and the second one, human-robot collaboration. Once application solution select the single module, they have to propose a solution for a maximum covering two functionalities. Also, this has to be specified in the template in the proposal stage. Both open call are targeting SMEs and startups, which definition can be found in this link here by the European Commission. However, we also inserted this table for you to understand better. There are three categories of company: medium-sized, small, and micro, with the number or the minimum criteria of staff headcount, turnover, and balance sheet total. Since it was one of the question of the last, let's say, info desk, micro company category, we mean startups. Natural entities are not allowed to apply because it's for, as we said before, SMEs and startups. That have to come from the eligible countries according to the same criteria of Horizon Europe, which are European member states and the Horizon Europe associated countries. There are two different configurations for SMEs and startups for applying to this open goal. The first one is the single application solution, which is just one third party applying and receiving the funds, and the twin application solution, which are two third parties applying, both SMEs or startup, that are gonna receive and share the 200,000 euro of budget. It's important to know that for the second configuration, which is twin application solution, just one company between the two is going to consider as the coordinator of this small consortium, and it will be the only point of contact with Magician counterparts in order to, let's say, facilitate the administrative part of the application, and also is going to be the coordinator receiving the funds and then sharing between the two companies. This is the funded scheme. As we said, application solution is 200,000 euros at funding rate of 70% for SMEs, reaching up to 100% in the budget in case of startups applying. The financement is going to be divided in three phases: pre-financing up to 50% upon the successful completion of the kickoff meeting, the intermediate payment of 35% that will be upon the submission and approval of a status report, which include the work packages, the risk assessment, and the financial report. And the third payment of 15% following the conclusion of the application solution after the 12th month and the successful achievement of milestones and deliverables. This is the application solution timeline. So the open call will close the 2nd of May. After that, the evaluation process will start. The evaluation is going to be based on three different criteria: excellence, impact, which include also a business case oriented description, and implementation quality. The evaluation will divide in three different steps. First of all, there will be the evaluation from external technical experts. Second of all, a business case evaluation that is part of the impact section. And third of all, the Magician evaluation committee that will make a global evaluation based on the results of the previous steps of evaluation. Each criteria is going to receive a score from 1 to 5. Each criteria is equally ranked. So the maximum score will be 15. However, the minimum total threshold is 9. In case of same score, once we have to select the successful proposal, the ranking depends on the best value given to the excellence part. So priority is going to give to innovation. Once the evaluation process finished, there's going to be the application solution selection. So 5 selected proposals will be received the first part of the funds. In case of remaining budget, that will be a potential for an extra solution for the second open call. The first call notification are planned for the 13th of June 2025. In case of grant, in case of selection, the notification will include outcomes and next steps information. In case of not grant, the notification will include the evaluation report with some, let's say, improvement in case you want to apply for the second open call. After that, there will be the signature of a sub-grant standard agreement before the implementation of the application solution. And the implementation will start with a kickoff meeting in July 2025 and will last for 12 months until July 2026. This is all the operational information you have regarding the open call. However, you can go to this website of Magician in the section of the open calls. Below all the information, you're going to have these 3 buttons: apply now for applying, get all information, that you will go to resources and funding section. Below open calls, you're going to have all the documentation you'll need. And then we remind that every Wednesday from 5 to 6, there will be the help desk to have even more information. Thank you. Now I leave the floor to the presentation of the key functionalities of integration of Magician. The first module, so perception, the perception module that is gonna led by Forth.
Jason?
Yeah, I think Amar is also here. He was the one to present it, but Amar, can you hear us?
Amar?
I think maybe
I think there is Antonis as well.
Amar is saying that he cannot unmute himself.
I can try. Maybe Margherita, if you can try to click on the 3 dots next to the name of Amal, there should be the option to allow him to talk with the mic.
I don't see him anymore in the list. I make him a
all right.
presenter, so he could speak. So probably he signed out and in again. And I was allowing him to present. Mark, can you now hear us? We see you are unmuted. Yeah, Mark, can you hear us again? You're a presenter. You have every right to unmute yourself and speak.
Yes, it seems it is.
Hello.
Unmuted.
So,
Yeah.
hello to everybody. So Amar is going to present from my office because there's a technical problem in his workstation. So the
Okay.
floor to Amar.
Sorry about the delay. With respect to the perception module, the pilot use case for the magician perception targets a variety of minor production defects in car manufacturing, as Professor Fontanelli already explained. To give some more detail, as you can see in this slide, we have a variety of different defects, like, for example, positive dents, welding spatters, negative dents, residuals of sealing material that's running through metal sheets, as well as material defects and deformations. And we need to be able to detect very small irregularities down to 300 microns, while also maintaining a very high throughput, because when we are talking about the surface of a car, I mean, you can imagine, you can see the dimensions of the car below. That we need to have this very high accuracy in a very big area. So we need to ensure that there is robust and reliable detection, and that happening across all of the diverse material surfaces and defect types. We also need to keep the scan time to below 1 minute in order to be able to support the production throughput of the factory, since every second that we delay it counts, because it basically delays the car manufacturing capacity of the factory. If we can go to the next slide. What Magician seeks as integrated functionality is non-invasive sensing modalities, for example, laser scanners, structured light, time of flight methods, maybe thermographic, eddy current, or ultrasound. These methods need to be real-time or near real-time in order to perform the defect classification on the commodity hardware that we have available. We need to have a scalable prototype that enhances detection accuracy and speed, supporting factory workers. And proposed solutions need to be seamlessly integrated with existing perception models that we develop. And the vision-based and tactile setup we have. Next slide. Okay. For the perception module, there are a lot of technologies that we have considered, ranging from monochrome and color cameras, hyperspectral cameras, infrared cameras, time-of-flight sensors, laser scattering, 3D scanners, and what we now use is a polarized camera system. In general, the requirements, as I already mentioned, is to have very high resolution, to have fast acquisition throughput, low exposure time, use a global shutter with respect to the camera sensor in order to not introduce any sort of defects in the sensor that do not correspond to ground truth. We need the clear image, and we need to cover a large area fast and with detail. So we have considered all of this. However, we seek alternate sensing technologies that are able to handle this large volume of data in real time. The perception module should also be fully software and hardware integrated using the robot operating system ROS2, which is the system that is powering the Magician robot. The camera system needs to be able to produce clear data that will be used by the autonomous neural network equipped robot, and it needs to comply to strict KPIs with respect to performance and accuracy. Next slide. With respect to defect removal and rework abilities, we are using the Dusan platform, and we have developed a specific end effector and control algorithm by also suitably modding commercial grinding tool. And thus we have already a solution to rework excess material. So, for example, positive dents or spatters that have extra material on the surface of the car. However, we would like to have more tools, for example, a hammer-like end effector for small dents repair, or other versatile end effectors for other defects. Of course, all these solutions should again be co-developed and designed with the Magician team in order to be able to be interchangeable using the same end effector and control algorithms, and help us extend support of defect removal and reworkabilities to more types of defects. Next slide. For annotating defects, of course, the multimodal data recorded from all the sensors generate data sets, and we have already developed a graphical user interface for annotation. Of course, we need to use lossless image compression in order to maintain all of the data. What we have developed basically works well enough. We can actually annotate each image using approximately 5 seconds. However, we are actively experimenting on semi-automating this data annotation by also using foundation models like, for example, DeepSeek or Segment Anything that may be used in the background to also take load out of the annotation and make it faster and speed up the development of the neural network training code. Next slide. With respect to the machine learning, of course, even if we have a top-of-the-notch sensing solution that has very high accuracy and produces very clear images, without a very good neural network, this is not useful. So we are also seeking a machine learning solution that works with the selected sensor solutions, whether that is polarized cameras or it's another modality. It needs to be able to be combined with the annotation tool in order to be trained on the specific samples. It needs to be trained with very few defect samples. So each partner right now has been shipped 50 samples. You can see on the bottom left image of defective metal. So it's what we call the few-shot learning. The method needs to be able to ignore annotation marks without overfitting on them. So if you see the metal sheets have a pen marker that shows the defects. So the neural network needs to be able to not associate the pen with the defect. And the trained neural network should be able to evaluate data in real time, to have very high precision and recall, to be able to classify both the defect type, if it's a positive dent, negative dent, the welding spatter, but also its severity, how bad it is. And also the machine learning solution should be extendable to other use cases. During the second open call, we might have more use cases than just the car manufacturing. So we should be able to support also these newer use cases. Finally, the machine learning solution should also be very close to the Magician robot again, maybe also share some GPU compute with other neural networks that execute pose estimation in order to be able to perceive humans. And yes, and for the next one, Michele, do you want to join us? Michele will also provide you.
Okay, so hello everyone. Just to give some information about the actual tactile system. The actual data collected by the system are the force exerted by the operator during a scan, and at the same time the acceleration of their movements. And these signals are collected by using a force sensor and an accelerometer. These two sensors are integrated in a tactile perception module, which has been designed to be modular in order to guarantee an easy integration along all the interfaces required by the Magician project. And this tactile perception module can be used together with different end effector. For example, we have a pulp probe end effector, which allow us to have pulp with different texture roughness in order to have proper defect detection through tactile data, or otherwise also by using a scallop probe, which has been designed like that to increase the area that is scanned during an acquisition. And thanks to the dance on the scallop, we have some variation in the force signal and in the acceleration signal, which enable us to correctly identify a defect over a surface. Then this module can be integrated in both user interfaces in order to collect data from the user exploration modalities. And then in order to replicate these exploration modality and the user skills can be also integrated in our robot interfaces in order to make able the robot to perform the acquisition by using the same skill of the operator. Next slide, please. So up to now, our work was focused on the design of a wearable solution and in a handheld solution. The wearable solution has been designed to be worn on the user hand by locating the sensor on the user perm, while the handheld solution has been designed to be held by the user, and this allows us to have more freedom about the end effector design, since the latter is not anymore an obstacle to the scanning movement performed by the user. Anyway, even if these two solutions have been practical for initial testing, they do not fully align with the natural exploration movement performed by a worker during the scan of a surface. So what we seek is the design of a fully wearable solution that ensures the natural movement by the worker during the scan. And to do this, we can explore alternative sensors such as black fiber sensor, which are minimally invasive, so they could be integrated in a glow solution that ensure more transparency during the scan movement. And then, of course, since we should explore this new sensor, it is also required to acquire a dataset in order to have a comprehensive testing of these new various tactile sensors, and that help us to have a comparison on which is the best option between this new sensor and the sensor that we are using right now. And I finished.
Thank you. Okay, now is the turn of the second module, human-robot collaboration module, and the technical description moderated by IIT.
Just a check, can you hear me well?
Yes.
It's fine, okay.
Yes, perfectly.
So I'm Davide Torielli, I'm working in IIT, the lab led by Nikos Sagrakis. So among the tasks of our group is about developing and integrating all the components of the various partners. So this is just a brief overview of what is the architecture, the hardware architecture and the software architecture of the robots that we are using. So on the left, we have the Dusan robot H2515, which comes out of the box with this control unit, always from the company. To this, we have a control unit that is separated from the robot, which is running our software framework, which is called the Crosspod 2 framework. This framework allows to communicate with the robot if necessary in real time. And to the other side, we can communicate to this control unit through the API provided in C++ or Python, but also this is fully integrated with ROS2. And so we can use the common standard interface to control the robot. To the robot, at the end effector, we have the mounting tool interface, which is different based on the interface that you have to mount. That can be, for example, the sensing tools, the tactile and the vision sensing tools for the sensing robot, or as I show in this slide, the sender tools that is used for the working robot that has to remove the defects. Inside this sender tool at the moment, we have a simple EtherCAT module that allows us to switch on and off the tool accordingly directly from the crossbow side, so with the API that we provide. Okay, the next slide, please. Thanks. About the functionality of this module, what we will present are 4 different functionalities. One is about the human observation, so human observation for learning the task. One is about communicating with the robot in an intuitive way, so this is about the human interface and the interaction that the operator has to do with the robot. Related to this, there is an interface based on a speaking system, so vocal commands, and on the bottom there are motion improvements for the robot that we would like to provide more mobile ability to the robot. Okay, next slide. So about the first one, with human observation, we mean that we want to learn from the user how to sense and how to work on the defects, to understand how the robot can mimic this behavior of the worker. So we want to learn from the experts. For this, we seek to have some motion learning techniques to provide approaches to observe the human, but also to adapt the human skill to the robot, which is obviously different from the human. And since this project is focused on employing these systems in real-world scenarios, we want this learning approach to be fast, so with, for example, with zero-shot learning, but also robust and generic, so we can adapt to different defects, also to different environments, and this will for sure help in providing these systems in real scenarios. And that's it, I think. Right. Thanks. About the second functionality is collaboration, is a more intuitive collaboration between the human and the robot. We want to integrate advanced interaction system between the user and the robot. These can usually, at the moment in the market, these are usually done with graphical user interface, but we would like to have more advanced features like, for example, the one offered by augmented reality devices, because these improve the interaction with the robot, helps also in the worker. The worker is more free to move around in the facility area without having to keep a screen on the hands, for example. And so the key features of this interface should have a two-way communication between the user and the robot to enable both commanding the robot but also receiving feedback, useful feedback from the robot according to what is happening at the robot side. The interface, all these functionality, this is valid for all the functionalities, but all the software provided must be compliant with the system that we are using. So we have to integrate all the technologies in the robots that we are using, but also in the software framework that we are using, that is Crossbow Do, or at least using a ROS2 interface, which is a pretty standard tool in the robotics. Yes, next slide. About the third functionality is a specific interface for the human worker, which is based on voice command. So the idea is to have this interaction with the robot in the most natural way possible, so by using the voice. This the important things about this functionality is that both the hardware must be robust, considering the working context that the robot is. So it should be noise resistant to noises that are present in these scenarios. And at the software side, we want also to have feedback based on audio together with this interface to convey important information about the user, like the fact that an action is correctly accomplished by the robot, or to request further guidance by the user because the robot has some difficulties in performing what is asked. And again, this system should be integrated in the framework that we are developing. Okay, next slide. This last functionality instead is in providing the robot with more functionalities. So at the moment, the system of Magician will develop this fixed manipulator in the facility, or at least we will have this manipulator on a slider, which is a one-directional slider. So we will have only 1 degree of freedom for the base of the robot, let's say. In addition to the degrees of freedom of the manipulator itself. So what we seek with this functionality is to integrate a mobile base to the robot, and this augmented the possibility and all the use case that we can have with the Magician project. So with this functionality, both the hardware should be integrated in the system, so integrating the arm in the mobile base, but also the software should be integrated. So new motion controller, for example, whole body motion controller should be integrated to control the robot and mobile base in a simple way. And then since we are adding this mobile base, and since the facility is in a real working context, it's also important to provide the mobile base with perception and navigation modules to allow the robot to navigate in the facility to ensure safety for the operators, but also for the robot itself, so avoiding obstacle and avoiding avoiding obstacle and avoiding humans. And again, this should be integrated in the cross-body interface, or anyway in a ROS2 framework that we are using. Okay, that's it.
Thank you.
Thanks.
Okay, we are now at the question and answer section, so we can open the discussion.
We have already replied on the chat about the terms of eligibility in relation to the fact of one organization being particularly linked or collaborating with one of the project partners. In this case, the rule that we have given is that an organization being configured as an affiliated entity according to the rule of Horizon Europe would in this case conflict with the evaluation, because there will be an internal evaluation conducted by the partners of the project itself. As long as this type of link or stable connection is not there are no conflict with the eligibility of the participant. Is there any other question from the audience? If so, we can unmute you one by one. I can see another one just thrown on the file. To determine if a company is a startup, is there a criteria connected with the company age, date of creation? This should be the case. There are definitions, but we will publish one that is the one that we officially report. In this moment, we make primary reference to the definition of SMEs that is given by the Commission, and this is our primary reference. We will put in the frequently asked question in the next days, also the key definition for startup, and in relation with the the timing and the age of the organization itself. I don't see other questions at the moment. One hand raised, and now I can
allow.
Thank you.
Yes, thank you. I'm Marco Ruzzon. Can you hear me?
Perfectly.
Yes.
Oh, perfect. Yes. So a technical question about both perception and actually also the grinding. So I saw that you show full chassis cars. So we need to expect that there is also some obstruction when performing both detection and operation on the defects. Is it right? So it's not just parts that we are inspecting, is the full chassis or partially assembled chassis of the car. So we need to take this into consideration when devising the solution for perception in under 1 minute. So there is maybe a lot of obstruction, and instead for manipulation, dexterity and maneuverability will be keys to explore all the areas inside the car. Or the removal of defects and inspection is expected to be just on the outside part.
So can you hear me?
Yes.
Yes. So very good question. Thank you. Basically, the car has some surface areas are covered because it also has its seats and its a lot of things that get assembled later in the car assembly process. The factory has its own, let's say, requirements. Defects are classified as Class A, Class B, Class C, depending on how visible they are. So, for example, if you have a defect that's underneath the car seat, it's not as important because then you will get the seat on. All in all, we do not have to deal with the whole surface, and we especially have very high priority on the very visible places, like, for example, the door or the bonnet. However, yes, the solution should be able to be maneuverable and should be able to look at the whole car and not just, for example, just one part. And so it's I don't know if I answered your question. But all in all, the solution needs to have some sort of maneuverability and be able to look at the car from like different vantage points and not just have like a fixed, let's say, location.
Yes, perfect. Thank you. Yeah, perfect for your answer. So I understand that also for the removal with the 6-degree robot with the mobile base, maybe you need to go and remove defects inside the car.
Yes, exactly. This is the first priority is to have the Class A defects, the ones that are very visible, that are outside, as I said. But this is something that we also want to do. These are the considered Class B or Class C defects.
Thank you. And one second question. So I saw that there is a timing for scanning, which is easier. Is there also a time constraint on removal of particular defects, depending also on their gravity, as you said? So there is classification on these available, let's say.
Yeah. So basically, Professor Fontanelli, do you want to answer? Or?
Yeah, go ahead.
Yes. So basically, we have two robots. So we have one robot that does the sensing, one robot that does the repairs. So both of them need to be able to work instead of humans that do the same work. Basically, as you may understand, when you have a factory that produces cars every like 1.5 minutes, if you just are late 10 seconds, this sums up and is devastating for the efficiency of the creation. So we need both of the robots to be able to have to perform comparably to the humans that do the work currently. I'm not exactly sure what's the sum of the time we have. I think it's maybe 1.5 minutes. But in terms of the sensing robot and the repair robot, they could also have some sort of parallelization. Since they will be able to communicate using Ethernet and they should share the same state somehow, have the same model of the car. So they would immediately, the sensing robot would immediately say to the repair robot where to do the repairs. So again, I don't know if I'm answering your question. There is a fixed time KPI, but the fact that we have two robots gives us some, let's say, space to maybe parallelize this.
Perfect. Yes, thank you. Thank you for your answer and also for the presentation. Thank you.
Thank you.
There is another technical question, I would say, in the chat, and is it from Gianluca Lentini. How is the demonstration phase currently performed in your imitation learning system, passive observation, kinestich, teleop? I hope some of the technical presenter can address this.
So again, if I may respond, we are given from the TOFAS factory. Of course, we have access to actual workers doing the defect removal. And what we are currently using, we are using a 3D pose estimation method in order to be able to do an inverse kinematic solution of their skeleton while they are doing the defect repair. So we have this thing, but also maybe Michele, if you want to also respond with respect to the TATs, we have this.
Yeah, but also for what regard the tactile system, up to now, it's everything is based on passive observation. So we are collecting data by measuring all the signals coming from the operator, and then on the base of this data collected by offline procedure, we could in future, for example, we can in future, for example, understand how to exploit these exploration modalities and this movement from the operator. We can know by using this how train the robots to perform the same task, let's say. I don't know if we answered the question. Okay, perfect. Thank you.
I see another question in the chat. Can you please explain in details what you are looking for regarding F1.3? I understand that you already have developed the software. You are looking for a replacement that could handle machine learning backend and multimodal data annotation. F1.4, actually. I don't know if maybe it's useful that we reopen the call for proposals so that to be clear on what is F1.4.
Yes, maybe this is a question for Ammar.
Yes. Sorry. So basically, first of all, we have each partner has 50 different, let's say, ground truth samples, and because we are concurrently developing the vision system. Every time we change the vision system, we change its intrinsics, we change its exposure, its resolution, etc. We might need to re-annotate the same number of defective material. So we have a need to be able to annotate data for the project. And basically, what we have is we already have a graphical user interface that you can use it to click the defect types, and this is pretty fast. However, we are also experimenting on using some foundation models, as I mentioned, that maybe are very slow to execute. I mean, they are not possible to use in the actual magician robot because of their speed. So if, for example, we have a vision language model that maybe processes 10 tokens per second or something. This is impossible to use to scan this whole surface using the vision language model. So what we want is to maybe have an annotation tool that uses this sort of technologies to automatically annotate the data we have in order to train a machine learning solution that works fast in real time. So basically, our needs are to improve this annotation tool and maybe have some sort of automatic or semi-automatic annotation using maybe a zero-shot method or like a very, very complex neural network. So this would speed up development and also would make it easier to adapt the magician robot for new use cases that will happen during the second open call. You also this was the question. Okay, yeah. I hope I answered your question.
Yes, it seems that all respondents are quite happy with the technical details provided, so thank you very much to all the speakers. We have still some times foreseen for this webinar in order to let participants have as much time as possible to present their questions. But if there are no more questions, we can also just close the meeting. And remember that we will have other occasions in order to receive your question even after this webinar. Every Wednesday at 5 we host an open help desk in which you can join us and ask further questions in case they come in the next weeks. This will be open until the end of the call for proposal timing, so until May 2nd, so the Wednesday before May 2nd. And in that occasion, we will be available really to speak rather than just dropping an email. We consider that this is a little bit more effective. All applications are more than welcome from, as we were mentioning, all applicants in Europe or associated countries of Horizon Europe. And we are looking forward to receive solutions that can enhance and expand the scope of the Magician platform under this call. I don't see any further question. Let me again thank all the presenters for their time and all the participants for their questions. We'll remain available as mentioned, and really looking forward to receive your ideas and proposal applications. This is a unique opportunity, as typically cascade funding opportunities under Horizon Europe are smaller in scale. So this is a very great opportunity in terms also of type of funding that you can receive and opportunity to collaborate with extremely advanced, innovative and interesting partners that form the consortium of Magician. So it's really an opportunity not only in terms of interesting resources, but also in terms of very interesting collaboration that you can have. So again, this is a call to apply and to continue to ask questions. And thank you very much for your time in today's meeting.
Bye.
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 Thank you. Bye-bye.